Okay, this is our fifth meeting, chapter 6. Let's go ahead and start the quiz and look at the questions.
Oh, yeah.
But it's not capital. No, it is 12:45. There's the capital gain. It's creative. We have a 47, 97. Come on, yes. Should I? What have we got on 47? That's when you go to Google.
Are you in? Okay. So question number 3. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? Why would it be skewed right?
So, like in reading, it says that if it's 30 or above, then it's normal. So if it's under 30, then it's just like what the graph tells you it is. So it says that the shape of the distribution of means histogram when the parent population is right skewed, it would just stay the same.
Yeah, the hint says the equipment sold.
Can you show me that in the reading just so I can look at it for future reference?
Okay. What did he say?
So then you did the land. Because I didn't read what skills that you bring to the table.
Oh, if n is greater or equal to 30, we will say the distribution of the sample means will be approximately normal. So it would be skewed right and not skewed left because the parent population is right skewed. Mm-hmm.
So it would just be the same.
So no change, just be skewed right. Do you agree, Russell?
Yep.
Okay, cool. All right, so this, for the next one, question 4, it is now greater than 30, so we'll say that it's normal. Question 5, n equals 5. What is the parent population when it's normally distributed? Would it still be normal?
Because that's how it was. It's telling like what are
So it's still normal. All right. So it's still normal for question 6 as well, because it's greater than 30, automatically becomes normal.
Right.
Cool.
I think.
That's what we're thinking. When would the distribution of means be normally distributed?
What I'm looking at right here is it's not a capital but it is 47, 97, part 2. Okay.
Yeah.
Because it can be multiple ones.
Oh.
What are you guys thinking?
Um, she thinks it's the second one and the fourth option.
Yeah,
Um,
I thought maybe it's. What do you think about the first one?
Data drawn from a small population and the sample size is small.
I definitely agree with the second and the fourth one, but I wasn't too sure about the first one. No, yeah, probably
Why?
not.
Why do you think it would or wouldn't be the first one? So how come you think it might be the first one, Russell?
Hold on, I'm reading this thing.
Oh, sorry.
Yeah, no problem.
If the parent population is normal, then the sampling distribution of X will always be normally distributed, no matter how many observations are selected. Well, it says in the little green box under 3.1 in the notes that X will be normally distributed if the data were drawn distributed if the sample size is sufficiently large. So option number 2, I think, is a given, since data are drawn from a population that is normally distributed and the sample size is large. So that is just exactly what it said that it would need to be normally distributed. So I think that one for sure is correct, in my opinion.
Or they're like, hold it one positive bill or another.
Yeah, why not? Because things crop up and say there's avalanche. Oh, Turner, yeah. Like that. The ad book you could be like,
So I think that maybe the first one, because I mean I might just be understanding this wrong, but it says if the parent population is normal, which it is, then the sampling distribution will always be normal, no matter how many observations are selected.
Meaning it doesn't matter if it's a big or small size, it all
Right,
still
exactly.
valid as long as the population is normally distributed.
Right, so that was my reasoning, but
So we're gonna go with 1, 2, and 4.
Yeah, I will. I mean, if you guys don't want to do it, that's fine. I understand.
Well, that sounds good to us. Can too. And not number 3, because you can't have small sample size if it's right skewed. You got to have a large enough amount of sample.
Exactly. You have to take a bigger sample.
Right. All right, let's move on to question 8. Which of the following gives the best explanation?
People the most know.
It's the fourth option. If the sample size is large, the shape of the distribution of sample means will be approximately normal. I just got that.
Yeah.
Okay. Question number 9. what is the mean of the distribution of sample means? It's just 10, right?
Yeah.
Standard deviation, just, no, wait. Oh, to find that one, we have to do 36 divided by, or no, 6 divided by square root of 36. So 6 over 6 is 1. So just 1. Okay, cool. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would the shape be? Just normal, right? For question 11.
What did you say you got for question 9? My microphone went out.
9, just 10. It's the same as the
Okay.
regular mean.
Right. Okay.
And then
I just
for question
heard
10,
you say something about it being 1. Yeah, and 10 is 1.
yeah, that's what I was talking about.
Okay. I just
Question
heard
9
the
is
1
10,
part.
and question 10 is 1.
Right. Okay.
All right. And then for question 11, we were saying normal.
Right.
And then what theorem would justify your response to the last question? The law of large numbers.
The large number.
Yeah, the law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller.
Right.
Do you have any questions?
Why is my computer so slow?
I think that's it. Any other questions, Russell?
No, I'm just.
I already did. We
My
missed.
computer's
It's
just-
the last one is the central limit theorem. That's the only one we missed.
Oh. Fool me once.
Yep, that's it then. We got it. That's the central limit theorem. I don't remember what it said. It said that if the sample size is large, the shape of the distribution of sample means will be normal. So because it's greater than 30, which is technically large, it's going to be a normal distribution. So that's why it's the central limit theorem. Got it. All right, I think that's it. You guys have anything else? Okay.
I'm good.
We'll be done. We'll meet on Wednesday, 2:15 here, same place. And we'll see you guys then.
Yep. All right.
All right. Talk to you later.